going to talk about 4 variable. K-map. So similar with the others, we start with one example. Okay. So suppose you have one function. So this is your function. So as you expect, the function f has 4 variables. So here the variables are a, b, c, and d. So it is the standard form. Whatever we saw for the K-map, the function should be in the standard form. Then you are able to use the K-map. So the function is this: sigma midterm 0, 1, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so this is what we have as a function, so which is in standard form, and we want to know what should be the K-map for the function with 4 variables. So before I start, somehow you could guess what should be the K-map should has how many squares. So whenever we had 2 functions with 2 variable, K-map had 4 square, right? So yeah, here definitely, whenever you have 4 variables, definitely what you expect to see a map with 16 to power 4 or 16 square inside that. So usually we draw the K-map for function with 4 variables in this way. So definitely you expect to see 16. So you actually have something like this. So here, similar with the others, the 2 variable with the highest value comes to one side, which is here. Usually we put A and B. If that xy and z here should be xy, okay. So, and the other side is CD. Or again, if you have xy, zw, so this side should be zw instead of CD, okay. So the order that we consider here, you put 0, 0, 0, 1 for here, 1, 1 for here, and 1, 0 for this. And same order here. So AB could be 0, 0, could be 0, 1, could be 1, 1, and could be 1, 0. Okay. So then each square should be get a midterm number, right? So help me to complete this. What should be the number of these squares that you see here? What should be its number? Yeah, that's right, 0. So see, similar with the 2 variables K-map and 3 variables. So these square, just check here. AB is 0, 0 here. CD is 0, 0, 0, 0, 0. So definitely this is 0. So this should be 1. This should be 3. This should be 4. Okay. So why 4 again? Because AB is 0, 0, and C is 1, and D is 0. So what we should have here, so the A is 0, B is 1, CD is 0. What should be then the midterm number for these square that you see? So just B is 1, the rest is 0, right? Yeah, you are right. So the last one shouldn't be 4. If you want to Talk about this. Definitely this is not 4. This is 2. I don't know. This is what you want to mention?
Yes.
Okay. Yep. You're right. So why? The reason is clear. So A and B is 0, 0. The D is 0 and C is 1. So C is 2 here. So definitely you are right. We should change that to 2, which I'm going to do that. Okay. So this should be 2. Okay. So how about this? Just B is 1, should be 4. How about this? Should it be 5? How about this? Should be 7. How about this? Should be 6. How about this? Should be 12. 8 plus 4. How about this? Should be 13. How about this? Should be 15. How about this? Should be 4. Yeah, 14. How about the next line is 8. This is 9. This is 11. And this is 10. For the same actually reason that I mentioned in the beginning. So far, nothing actually different. The only thing actually is different. We just have the K map with 16 square inside a map, right? So let's do change the color, and similar with the 2 and 3 variables. Just take a look to whatever you have here, and whatever you have as a midterm, you should actually put here as a 1. So midterm 0 should be 1, midterm 1 should be 1, midterm 4 and 5 we have 1, we have 6, 7, this is 6, this is 7, we have 8 and 9, so this is 8, this is 9, we have 10 and 11, we have 10 and 11, okay? So remember in the function 2 variables, usually whenever you have, sorry, for the function with 3 variables, whenever we had this K map, usually say you consider this like the cylinder that you see, and whatever you have in this side is the neighbor with the other side, okay? So here is almost the same story. You need to consider this something like this, okay? So that means whatever I have here is the neighbor with this one. So that means 2 is the neighbor with 10. 3 is neighbor with 11. So whatever you have in the top row is neighbor with the bottom row. Same thing for left and right. So whatever you have on the 2, 6, 14, and 10 is the neighbor with 1, 4, 12, and 18. So that means you could consider 2 and 1 as a one group with 2 members, okay? Just remember this, which you did the same thing for the function with 3 variables, okay? So with keeping this in our mind, so let's do back to our job. So the rules is the same with what we had for 2 and 3 variables. So again, the idea is selecting the minimum number of the group, and their member should be maximum, okay? So let's start with, as usual, we say, okay, group could be has 1 member, 2, 4, 8, 16 is maximum, right? So that means we start with check with 16. Do we have, could we select one group with 16 member, yes or no? Type on the box. Definitely no, because if you want to have the group with 16 members, all of them should be 1. You could actually get the group with 16 members. So you refuse this. How about the 8? Do we have any groups with the 8 member? No, again, no. So if you had on 12 and 13, definitely you could actually select these 8. So if you had, I don't know, 4 on 0, 4, 12, 8, and another 4 in 2, 6, 14, and 10, you could consider these 4 with these 4 is neighbor and could make a group with 8 members. So definitely you refuse to have the 8. How about 4? Do we have any group with 4 members? Definitely the answer is yes. How many? Answer this. How many group with 4 members we could make here? Yeah, that's right. So 3 should be right. So see, this is one of them. Okay. So this could be the second one. Consider all these 4 1 that you have. Just be careful. If you consider these two as a 2 members group with 2 members, it's actually doesn't give you a simplest form. It is right, but it's not end up with the simplest form because the rule is number of the group is minimum, their member is maximum. So here you could have actually this group of 4, which will give you a 3 group with 4 members. That's actually the best things that you could do, which give you a minimum number of the group and their member is maximum, which is here is 4. Okay. So then simplify that. So again, for simplify that is again same thing with we already know. Okay. So first consider this group of 4, which is midterm 0, 1, 4, 5. So again, 0, 0 will be get the prime, 0, 1, 1, 0 will be eliminate, and 1, 1 you keep that variable. So how about this 4? The A here is 0, 0, get the prime. So here again, the B is 0, 1, it's gone. The C is 0, 1, get prime. And D is 0, 1, again, no D. So that means the corresponding term for this group is A prime C plus. How about this? Let's write this one. So see this one. So 8, 9, 11, 10. So again, so see if you move here from 8 to 10 in these row, definitely C and D will be changed to the 0 and 1. So that means no C and no D, because whenever you move from here to here, definitely you got 0, 1, 1 to 0. For CD, no CD. And how about A and B? All the time, whenever you are in these groups, so the A is 1, B is 0. So you got actually A, B prime. Okay, plus. Okay, I don't know what's happened here in my notepad. So should be just plus, right? Or. So, and finally, this one is one that you see, writing the corresponding term for this. So again, C and D again change from 0 to 1, 0 whenever you move in these 4 members. And just A and B, A is 0 and B is 1. So that means you will have A prime and B, okay? So which is the simplest form of the function? Just that we double check one of them. So let I just double check and make sure we didn't leave anything wrong. So A prime C prime is right. So A prime B and C, the last one that we have here, which is A prime B. And how about this? This should be A B prime. A B prime. Why? Because so C, whenever you move CD, definitely will be 0, 1, and A here is 1, which is A, and B is 0, which is prime. That means A B prime, A prime B, and A prime C. So it looks actually should be fine. So if one of you actually tells me, okay, I'm doing the same thing, I end up with this K-map. So let I show the second scenario that could be happening here, because you didn't ask about that, I asked that question. So let's you have similar table. I'm doing the similar things that similar table that you see on the top. So I'm writing the same thing, okay? So which we have, I'm not writing the number of the midterm, that's exactly same what you see here. So we have 1 here, 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 1 here, 1 here, and 1 here. Okay. So if one of you tell, okay, so I'm doing this group. So see, I select this one. Select this one that you see. No, not this one. So let's try end up with. I want to get something different. So let's don't give these two, because if we do that, we end up with the same thing that we have on the top, which I don't want to. The same thing. If you do this, if someone tells me, okay, I select these four similar with what I did. I select these four, which is another group. So I'm not taking this with these two, because I told you whatever you have in top is the neighbor with the bottom. If someone tells, okay, I'm selecting this with these two that you have here, okay, so which you have here. So it says, okay, it should be right, because here you have three groups with 4 members. Here I have 3 groups with 4 members. What is the difference? Is it either right or wrong? Because I'm going to end up with something different. So I'm writing the same things for the second option that we have, okay? So the first term, which is, there is no change for last 2 terms that we have, because we have the same group with the up one, okay? So here you have this one, which is same. That means A, B prime is right, and A prime is same, because we have the same group here. But what it's changing in the second one, here we change the group from 0, 1, 4, 5 to 0, 1, 8, 9. So that means definitely we will change these terms that we have. Let's see. So here, if you write again here, the AB is 0, 1, there is no A. So how about B? B here is 0, here is 0, so that means should be changed to the B prime. And how about C and D? So again, C here is 0, 0, you got C prime, and D is 0, 1, it will be gone. That means you almost got the other terms. So the question is these two is the different, or these are the same? Because the rule that we have here is the same, because here you have number of the group 3, right? So their member is 4. Here you end up with the same thing. Here we say I have 3 groups and the number of the member is 4. So that means I exactly follow the orders that tells me should be end up with the simplest form. So also you see 2 different actually term here, but from simplification point of the view, these 2 term is exactly same. You tell me why. Why these 2 is the simplest form and there is no difference between these 2? The answer is, okay, check number of the OR gates that you need here is 2. Number of the AND is 1 here, 2, 3 here. Similar thing here, you 2 OR and 3 AND, right? So how many NOT do you need here? 1, 2, 3, 4. 1, 2, 3, 4. Okay. So that means also you end up with the 2 different form, but from actually simplification point of view, these are almost the same form. That means you need the same gates for implement this one, and also the same gates with this one. So that means no matter if you end up with the different groups, if you just follow these order, definitely you will end up with the simplest form, which is the same number of the gates. Okay. So that's actually the one thing you need to consider, and don't say, okay, this is wrong because this is not similar with this form. The both is right, because as I mentioned, if you implement this, they are exactly need same number of the gates and the configuration is almost same. We have a function, so the f is x, y, z, w. Okay. So it is equal to sigma midterm 0, 1, 4, 6, 7, 10, 11, 14, and 15. Okay, so this is a function with 4 variables. The question is simplify this function using the K-map. So you already know what we need to do. Okay, so you have the K-map should be 16 square, so you just draw a K-map with 16 square in it. So you have XY here, ZW here. So 0, 0, 0, 1, 1, 1, 1, 0. Similar, 0, 0, 0, 1, 1, 1, 1, 0. Write the midterm numbers because we already did, just I'm writing that very fast. So this is 0, this is 1, this is 3, this is 2. So this is 4, this is 5, this is 7, this is 6. So this is 12, this is 13, this is 15, this is 14. So this is 8, this is 9, this is 11, and this is 10. So just take a look inside the parentheses, the standard form, and see which midterm you have. So 0, 1, 4, 6, 7, 10, 11, 14, 15. Okay. So, yep, it looks right. So, just help me to finish this as fast as we could. So, what do we have any group with the 16 member? Yes or no? Type on the chat box. Yes, no, 16, no, definitely. If it's 16 should be 0, should be 1. So how about 8? Do we have any 8? No. So you couldn't actually find the all 8 should be in the neighbor, which we don't have. So how about 4? How many 4 we have? Definitely we have 4. So the question is how many? So some of them is obvious. So C, yeah, it looks there. That's right. Should be 2. So this is 1, 2. This is the other one is 2. Did I put any of them in the 4? The answer is no, because there is nothing here. There is nothing in the other side. So it looks for these 3, you just have these option. That means you could take these as a 2, and this is an output. So with doing that, it looks you actually, the number of the group will be minimum and their memory is maximum. The only thing is that we need to do, write the corresponding term for each of them. You could start to writing for anyone, it doesn't matter, okay? It doesn't matter. So yeah, we just be careful, don't keep these last one as a 1. You could make 2 here. Again, the number should be maximum, okay? So just don't put in this as a group with 1 member. It's not give you a simplest form. Because here you have the option. You could actually have 2 with the 2 members, okay? So write the corresponding term for each one. You could start from any one, it doesn't matter. I start with this one. So what we have here, so the xy is y here. Whenever you have this group, x is 1 and 1, you have x. Y is 0, 1, eliminate. So ZW, Z is 1 and 1, you have Z, and the W is 1, 0 is gone, plus. Write another one for these 7, 6, 15, 14. So the X is 0, 1 is gone, Y is 1, 1 should be Y. And what else we have? So again, Z is 1, 1, and the W is 1, 0 is gone, plus we have 2 here. So the XY is for this one, XY is 0, 0 should be X prime, Y prime, XY, Y prime. So, and ZW, Z is 0, 0, you got the Z prime here, and W is 0, 1 is gone for this. And for the next one, which is the last one, x is 0, 0 should be x prime. So the y is 0, 1 is gone, and the zw for this group is also z, so it should be z prime w prime. Okay, so this is a simplest form of the function. So the question is, you have one function, so the function f has 4 variables, so it is x, y, x, z, and w, and it is in the standard form. So the standard form is whatever you see on the screen, which is sigma mean term. We have 0, we have 1, we have 2, we have 6, we have 8, we have 9, and we have 10. Okay. So the question is, simplify this function with using the K-map. So there is actually nothing new. It is similar with what we did in our last class. So we have a function with the 4 variable. We want to use the K-map and get the simplest form of that. Let's see. So let's see how we could get that. So as usual, we just need a table with 16 squares. So you make the K-map for the function with 4 variables. Okay. So we make something like this. So usually we put x, y here, zw here. So 0, 0, 0, 1, 1, 0, and sorry, usually we put 1, 1 here. So 1, 1, and 1, 0. So 0, 0, 0, 1, 1, 1, and 1, 0 here. Okay. So nothing new so far. So each of these squares should be specific midterm. So you just take a look to the value that you have for that square. For this one, xy is 0, 0, zw is 0, 0. So it should be midterm 0. Similar with this, it should be 1, it should be 3, this should be 2. So same, it should be 4, this should be 12, should be 12, and this should be 8. So this should be 5, this should be 13, this should be 9. So same, it should be 7, should be 6, should be 15, should be 14, should be 11, and should be 10. Okay. Yeah, some crazy thing happening here. So that's 10. So back to here, just take a look to whatever you have inside these parentheses and put that midterm as a 1. So you have midterm 0. I just put 1 here on the 0. You have 1. You have 2. You have 6. You have 8. You have 9. So we have 1 here. here, which is 9 here. So what else we have? We have 10. So we have 1 also here. Okay. So 1 here, 1 here, 1 here, 1 here, 1 here, and 1 in the 0. Okay. So as usual, we just consider the group with the possible maximum members. So the members could be 1, 2, 4, 8, and 16. So definitely we refuse 16 because you couldn't select a group which is cover all these 1 and able to have 16 members. Okay. So how about 8? Do we have any groups with the 8 member? Yes or no? We have 8? No, definitely no. So how about 4? How about 4? How many 4 we have here? We have 1, 4. So let's see. So 1 is definitely is obvious. So you could say these 2 here with these 2 here are neighbor. And could we make one group with 4 members? So this is 1. So could we find any one more group with 4 members? So the answer is yes. So see, this one is here. This one is neighbor. This one is neighbor. Okay. This one with, if you keep these as a common, this actually is neighbor with this one. Okay. And also, if you consider these as a common member, again, this one is neighbor with this. Okay. So that means the next, it is 2, 10, 8, and 0 could be other actually group with 4 members. Okay, which is somehow a little tricky, but it's there. So whenever you have in the corner for 1, definitely that could be a 1 group. Okay, so which here we did. So how about this 6? 1, 1 left here on the midterm number 6, right? So could we put that inside the group with 4 members? So the answer is no, we couldn't actually put inside any group. If we have 1 here at the 4, we could say these 2 with these 2 could be one group with 4 members, but we don't have 1 here. So that means definitely the only option left is just keep this 1 as a one group of 2. So that means we have 2 4 group plus 1 group with 2 members. That's the best thing you could do to get minimum number of the group and with the maximum members inside them. So then you just simplify that. So for each corresponding group, you could write the term. So start with this one, 0, 1, 8, 9, okay? So first check the x. X here is 0, here is 1, the x is gone. Y is 0, 0, so you will get y prime here. How about ZW? So again, you are here and here, so Z here is 0, 0, should be get the prime. And the W is 0, 1, no W, should be gone. Plus. Go to another group, which is the group of 4 in these 4 corners that we have. If you move in these 4 corners, first let's start with the XY. So here x is 1, here is 0, it's gone. So y is here is 0, here is 0. So again, you will have 1 prime. Check the ZW. Here z is 1, in the other side is 1. This will be gone. W here is 0, here is 0, should be prime. Okay. Plus. We have one group with 2 members here. Again, check it. X here is 0, 0. So you will get x prime. And how about y? Y is here is 0, here is 1, 0, 1 is gone. no y, back to the z, w, y here is 1, here is 1. So sorry, so we are actually here, we are here, right? We are here. So the z is 1 for both of them, and the w is 0 for both of them. That means you should have here z, w. Okay. So y prime, w prime, y prime, z prime, and x prime, z, w prime will be the simplest form of these function, and we make sure we could say this is the simplest form. You couldn't get more simple than this form that you see, because we follow the rules. The number of the group you could select is minimum, and they have the maximum number members inside that groups. Okay, so that will be the simplest form of these function.